Alright, this lesson is for section 9.2 on adding and subtracting polynomials. So that's what our target is for today. We're going to actually add and subtract the polynomials that yesterday we were naming and classifying. Today we're going to be combining like terms and grouping like terms together. So let's start off with just a review of what a like term actually is. In this first set problems here, all I want to do is identify which terms are actually like terms. Now remember, you have to have the same variable and the same exponent. So in this particular example here, 3x and negative 2x, those are like terms. 8x squared would not be a like term because that exponent here is 2. Now in B, again, you want to look at the variable part. So I just look at this part. I don't even look at the leading coefficient in front. I don't look at that coefficient because all I care about are the variables and their exponents. So the first one says x squared y. The second one says x squared y, so this also would be two like terms here. But the third one, because it's xy squared, would not work. So it's only the first two terms that we would consider like terms. Finally, in the last example, here we have 1x, 8x, and negative 4x, and because, again, we only look at the variable part, and all of them have x to the first power, all three of these would be like terms, so we can circle all three. Okay, now in example 2, we're actually going to combine like terms. Instead of just circling them, we're going to combine like terms, and then the resulting polynomial that we are left with, we want to identify that by degree and number of terms, just like we classified them yesterday. So let's start off, when we look at example A here, I have this first term here is negative 8x squared. I want to look for another variable part that has the x squared. So here I found another like term. Notice I'm circling the sign out in front. So what I type in my calculator would be negative 8 plus 3. Okay, it's important to get the sign out in front of it. So negative 8 plus 3 would give me negative 5x squared. Now I'm going to move on to the next term. So I just kind of cross those out as I go along. And I have negative 5x cubed. And I'm going to combine that with negative x cubed. Okay, again, grab the sign out in front of it, and then now in your calculator you can enter negative 5 minus, there's a 1 here, so negative 5 minus 1 is what I would type in, and I get negative 6x cubed. Then finally, after I cross those out, I'm left with just this positive 1, and since I have no other like terms to combine that with, I'm just going to drop that down. Now, the last thing I want to do when I look at this answer here is rearrange these so that they're in standard form. And as we learned before, standard form means that we're going to put the exponent with the term with the highest degree, which would mean the largest exponent, that's going to go first. So I'm going to rewrite this as negative 6x cubed, then negative 5x squared would come next. So I write that as minus 5x squared, and then finally it's positive 1, so I'm going to write plus 1. So that's my final answer here in standard form. So if I were to name this by the number of terms, we would call this a trinomial because there are 3 terms here. Now the degree of this polynomial would be cubic because of that 3 here, so we're going to call it a cubic trinomial. And the lead coefficient, in this case, is negative 6. Alright, now in the next example here, again I'm going to go through and just look for like terms. So I start with this 3 here, and I notice that there's another constant, negative 14. So I type in my calculator 3 minus 14 to get negative 11. Cross them off as I go. And then the next terms, negative 5x and positive 4x would give me a negative 1 when I type that in my calculator. So I'm going to write that as negative 1x. And I can leave off the 1. Either way is okay. And then finally I'm going to rewrite this in standard form. So obviously this negative x is going to come first and then minus 11. Alright, so if I'm going to name this by terms, since there are 2 terms, we would call that a binomial. And on this particular polynomial, the degree here is 1. It's an invisible 1 there, but we're going to call that linear then. So we have a binomial that is linear, and the lead coefficient here is negative 1. Okay, so now we're going to get to the whole point of the lesson, which is to add and subtract polynomials. So this is really similar to what we were just doing with combining like terms. It just, the problems look a little bit different because both of our polynomials here are in parentheses. Okay, but it doesn't really change what we want to do here. We still want to combine like terms. So the parentheses here actually don't really matter because I don't have to distribute anything out in front, right? There's only a 1 right here out in front, and there's a positive 1 here out in front as well. So I wouldn't really change this polynomial if I distributed that 1 to everything. So I'm going to go ahead and just drop the parentheses. Okay, so those parentheses, pretend like they're not even there. Now that problem becomes really similar to what we just worked on. We're going to look for like terms. So I start off with this 3a squared. and I look over here at the other polynomial here, and there's a positive a squared right here. So I type in 3 plus 1, I get 4a squared, and then I move on to the next term. So here I have 2a, positive 2a, and over here in the other polynomial I have a negative a. So 2 minus 1 gives me 1a, so that's a positive 1a, so I write plus 1a, and these are done. I move on now to negative 3, and over here in the other polynomial I have a negative 9. So negative 3 minus 9 in my calculator gives me negative 12, so that's minus 12. Finally, that a cubed here is the last term. It has nothing else to combine with, so I'm just going to drop it down as positive a cubed. And then obviously I want to rewrite this in standard form. Now if I rewrite this in standard form, this a cubed has to come first because it's the highest exponent, so I would rewrite this as a cubed. Then next would be 4a squared, so plus 4a squared. The next term after that would be a positive a, and I can drop the 1 in this case. You don't have to drop it, you can keep it in there, but I'm just going to drop it. Call that just plus a, and then finally the last term here, minus 12. So this would be my resulting polynomial, and because it has 4 terms here, we would label that as a polynomial, and because the degree here is 3, the highest degree, we'd call that cubic. Okay, now in our next problem here, it's just a little bit different than the last one, because if I just kind of erase over here, you notice that we were adding the two polynomials here. Now we're subtracting it, we're finding a difference. And because we have that negative out in front, the parentheses do matter. Now this time we have to distribute a negative 1, which will change all of the terms to their opposite sign in this other polynomial. So the first polynomial is actually going to stay the same. I'm just going to drop down all the terms, exactly the same. But then here I'm going to rewrite all of these terms. So since I'm distributing a negative, that 7x cubed now turns to negative 7x cubed. This 5x squared now becomes negative 5x squared. And that negative 3 becomes positive 3. And then from here I just go through just like I did in the last problem, and I look for like terms. So I'm starting with this x cubed, and I have a negative 7x cubed here. So I type in 1 minus 7, that gives me negative 6x cubed. The next term here, negative 8x squared and negative 5x squared. When I type in negative 8 minus 5, I get negative 13. So it's negative 13, then x squared. We can go ahead and cancel out all the terms we've already used. And then when I look at the two remaining terms here, I have a negative 2x and a plus 3. Neither of these can be combined, so I'm just going to drop both of them down. So I have negative 2x plus 3. So this is my final answer here. And on this particular example, it's actually very similar to the last one with how we are going to describe this and classify it, because we have, again, 4 terms. So we call that polynomial. 4 or more, we always say polynomial. And then because the degree here, the highest exponent is 3, we're going to call that cubic. All right. Okay, that's the end of the lesson. Tomorrow we're going to get a lot of practice with adding and subtracting polynomials. Good job. See you in class tomorrow.